Hello guys, in this video we are going to talk about wired media. Now I told you about wired media that are copper cable, coaxial cable and fiber optic cable. These are the medias which are included in wired media. Today, as we already looked at coaxial cables and fiber optic cables, now today we are going to look at two types of copper cable, two types of Ethernet cables. Now those are, first is unshielded twisted pair cable, second one is shielded twisted pair cable. Now these are two types of different cables. What is the difference between them? You might be seeing here that why this is called twisted pair, because there are a lot of twisted pairs, 4 twisted pairs here. There are also 4 twisted pairs, but this one is shielded. Some type of foil paper kind of thing is wrapped over it. So why do we shield it? We basically shield this thing because look, our signals are being transmitted via these cables. So our signals are transmitting in these cables. Any outside signal might interrupt our signals so that they can get modified. To prevent our signals from getting modified, to prevent external signals, external electrical signals to interrupt with our communication, to prevent this thing, we shield our cable. And if you are from non-medical stream, you might have read about cavity in electrostatic and stuff like that. There you probably would have read about that. How does this happens? I'm not going to explain that here, it won't be possible. It is a deep concept. However, just keep this in knowledge that we do shielding here to prevent external signals, external EMI and RFI networks, to interrupt our communication. This is the reason why we shield this. And here, as this is unshielded, there is a chance that the signals that are being transmitted in these cables might get interrupted. Alright, now here we also have a precaution to prevent our signals from getting interrupted. We can say it as a measure that we can take to minimize the risk. So how do we do it? Now that interruption is called crosstalk. So as UTP cable does not use shielding to counter the effects of EMI and RFI, thus negative effects of crosstalk can be limited by crosstalk, that is interruption of outer signals, can be limited by increasing these twists per pair. Alright, they are kind of, you can, if you are able to see, then 1 2 3, just imagine there are 3 twists in this cable. If you make them 6, then the risk of interruption will be minimized, will be less than what it was earlier. Alright, so this was a measure that we can take in UTP, and this was basically the difference among UTP and STP. These both are copper cables. However, now you know the difference between them. Now talking about the difference between fiber optic cable and copper cable. Here you can see the copper media and fiber optic media do possess a lot of differences. First of all, the bandwidth supported here is in copper cable is from 10 Mbps to 10 Gbps. However, in fiber optic cable, it goes all the way from 10 Mbps to 100 Gbps. So we can say we can achieve quite a higher speed in this fiber optic cable. Alright, now distances that they can cover, relatively short they are, because they can cover up to 100 meters. However, they can cover up to 1 lakh meters. Immunity to EMI and RFI, the outer signals that might interrupt. We talked about them, right? These are those outer signals which might interrupt our communication. In copper cable, the immunity is low. Of course, it is low because it is prone to, it is of course not that high, possessing that high immunity towards prevention towards these external networks. However, our fiber optic cable is completely immune. Now, immunity to electrical hazards is also low in copper cable, but high, or we can say completely immune, in fiber optic cables. Media and connector costs in copper cable is lowest. However, in fiber optic cable, the cost of media and connector are quite high. In fact, highest. Installation skills required here in copper media in copper is low. However, on the other hand, on fiber optic cable, you require high installation skills. Okay. Safety precautions are lowest here in copper. However, they are highest in fiber optic cable. Alright, so these were the differences among copper media and fiber optic. Okay. Now moving further, we are going to talk about line configuration. What line configuration is. Okay. Before that, let me tell you about wireless media. Now, basically there is a quite short topic in wireless media. The areas of concern, the things which we should concern about, which we could be concerned about, are coverage area, the interference, and security. Alright. Now, in line configuration, coming back to our topic, that is line configuration. Basically, it is the communication link that connects two or more nodes. So, what line configuration is? You can simply say it is the connection that is connecting your computer to the another device. Okay, or your computer, your node, to other many more nodes. Now, it can be wireless or wired. This is line configuration or connection. Now, the types of line configuration. At first, we have point-to-point connection and multi-point connection. As it is written over here, it is a communication link that connects two or more medias. Here, two medias are being connected. Here, more than two medias are being connected. So, what point-to-point connection is? Dedicated link between two devices. The entire capacity of the link. That is, suppose my computer and your computer is connected via an Ethernet cable. For instance, we are connected via Ethernet cable. Now, that whole Ethernet cable, that we can say that one Ethernet cable is totally dedicated to our communication. No other computer, no other node is using that Ethernet cable except us. Alright, this will be a point-to-point connection. Coming back to the definition, the entire capacity of the link is reserved for transmission between those two devices, as I aforementioned. Now, coming on multi-point connection. What multi-point connections are? Well, here more than two devices share a single link. First of all, let's see what the definition says. Now, more than two devices share a single link. Okay, so the cable that was at first totally dedicated towards the communication among two devices is now carrying out communication of more than two devices. So the capacity of the channel means path, the path via which your data is going. Okay, so the capacity of the channel, here the channel is that communication link. Okay, now the communication link is shared now. Except you, there are other nodes too that are using that communication link now. Well, explaining you here. Look, this single link is being shared by many computers. We can see that thing. We can see multi-point configuration. We can see multi-point connection in bus topology, where this single link is being shared by these many computers. Now, if somebody has to send the data to this computer, it could be that this computer and this computer are sending data. Both are sending data to this computer. So this link at the same time is being utilized by more than two computers. Alright, so this was about link configuration, and here we are done with our introduction to computer networking. This was the first chapter of our course. Now from tomorrow we are going to start chapter 2, that is data link layer. In that, we'll be studying in detail the protocols of data link layer and basically everything about data link layer. And up till this point, we read about introduction to computer networking. Moreover, we can say this was a broadened overview of what basically computer networking includes. So thank you guys for watching this video. I hope you enjoyed the session.